Good evening, students. We have our video, our next one, on literal equations. So we started working on those word problems in class, and we're going to continue working on the word problems. You're doing a great job with it. I know it hasn't been easy, but we're not going to send any of those home. Instead, we're going to continue on with the next topic in Algebra 1, which is solving literal equations and formulas for a given variable. So let's get started with our first part of the video. So we have to talk about what do we mean by literal equations and formulas. Well, many problems in algebra require the use of a formula for a solution. Formulas are simply equations that express a relationship between more than one variable or letter. You are already familiar with a number of examples used in pre-algebra. For instance, you have here percent equals rate times base, which is the percent equation, which is used to find percent of a number. For example, what is 5% of 20? And to find that, you're going to take your P equals RB formula, R times B there, and you're going to put 20 in for the base, because that's the whole value, and then you're going to put in the rate for 5%, which is 0.05. And that's going to give you that percent of that number. So that's one formula that, if you know how to use it, can be pretty easy to use. 5 times 20 would be 100, 2 decimal places, I believe. 5% of 20 is going to be 1. Then you have the second one here, A equals 1/2 HB. Hopefully you recognize that as the area of a triangle. So if you were to have a triangle with a height of 3 inches and a base of 5 inches, you can use your formula A equals 1/2 times 3 times 5, so half of 15, so 7.5 square inches for that one. And then you have this formula, which is perimeter of a rectangle. So we have perimeter of a rectangle, and if I had 5 here and a 20 here, it would be perimeter would be 2 times the length and 2 times the width, which ends up giving me 50. 2 20s is 40 plus 10, yes, 50. And what should be, let's say it's centimeters. So there's formulas. That's using formulas. We already knew how to do that. What we're going to do now is manipulate formulas. Move the variables around until they're solved for the variable we want. So here's our first example, solving a literal equation, and this one in particular is D equals RT. I wish they wouldn't have the dot, so I'm not going to use the dot when I rewrite it, but D equals RT, and we're solving for T. We want to get T by itself. So just like I would if I had a coefficient on T, where say it was like a 3, so if I had, say I had 15 equals 3T, that's the same idea. The 3 would be in the place of the R, so the 3 would be in the place of the R, and the 15 would be in the place of the D. And our whole goal when we solve an equation for a variable is to isolate that variable. So in this situation, T would equal 5. Now over here, what we have different is that D and R are also variables. So we're trying to isolate that T, so we're going to subtract the value that's actually the coefficient of T, or whatever is multiplying T. So what we're going to do is we're going to divide both sides right here by R. And this R is going to cancel, and we're going to get T by itself equals D over R, and we're going to use our symmetric property to present our answer, D divided by R. Now think conveniently about this particular formula right here, which is distance equals rate times time. In the distance equals rate times time problems, you've got the rate, say for example in miles per hour, and you're multiplying that by the time, say in hours, and you're getting the distance in miles. Now that's great if what I've been given is the rate and the time. But say that I had been given instead the distance and the rate. I could take it and divide. Distance divided by the rate, miles per hour, and you actually get it with an answer that ends in hours. So that would be one convenient reason to solve this equation for T. You might also solve the equation for R. Okay, so it depends on what you're asked to do, and each different way would be useful in a different manner. Moving on to example 2, you've got your perimeter formula for a rectangle. P equals 2L plus 2W. And they want us to solve it for W. So we want to get this W by itself. L. They want us to solve for L. So we want to get this L by itself. Again, just like we would with an equation, most of the time we'll start with addition or subtraction and then finish off with multiplication or division. In the previous question, we just had to divide. It was like a one-step equation, but this one is 2 steps. I want to first isolate the 2W by getting rid of the other thing that's on that side, which is the 2L. Now, P minus 2L, I can't simplify that. I can't match them up and say that there's any actual subtraction happening there because I have 2 completely different variables. So at this point, I've isolated 2W, but I have one last step to finish off, which is dividing by 2. Because again, we're trying to get that W by itself. Use your symmetric property once more and rewrite your answer. And there's the equation solved for W. So if I had the perimeter and the length of a rectangle, I could find the width, and so on. There are useful moments for this kind of skill. Plus, this is a very important skill if you're ever going to be dealing with scientific formulas of any type. The third example is a simple interest formula. The principal is the amount of money you have in the account, or the amount of your loan if you're talking about a different kind of interest. The R is the interest rate at which it's supposed to be growing, and the T is the time in which it's in the account. The A gives you the amount of money in the account at the end of time T. So this is a good formula, very important one in banking. Although interest is compiled continuously, which is very different from this particular formula, but this is a great formula to use to kind of plan and predict the general amount of money you're going to have. So we want to unwrap R. R was multiplied by T, then 1 was added, then the quantity was multiplied by P. Undo the last thing that would be done, which would be the multiplied by P. So you have to divide by P. And remember that cancels out, just like when we did that with numbers. And you have 1 plus RT. So you want to get rid of your 1. And at this point, you have just RT on the right-hand side. I'd like to divide by T, but that's going to get a little iffy, a little complicated over here with the fraction. So instead of dividing by T, how about we multiply by 1 over T? Leaving us A over PT minus 1 over T equals R. So it's quite a bit more complicated, but if you had an amount of money you wanted to have in your account, and you had an amount of time, and you had the amount that was in the account to begin with. So if you have A and P and T, you could plug them into our new formula and solve for R. So you'd be able to find the interest rate you needed in order to get what it is that you want. Okay, one more example. This one has a big fraction in it. So example 4, D equals C minus S all over N. This particular formula has something to do with taxes and valuation, and I'm not exactly sure what else. So pretend we don't need to know about that. We're just going to solve this formula for C. It'd help if I had a writing tool. D equals, there it is, C minus S all over N. Well, we got to get rid of that big fraction. That C is in the numerator. We have to get rid of that denominator. So ND equals C minus S. Finish off by adding S. N times D plus S is equal to C. And it looks awkward with that capital D, but very few of the examples we actually do in class, or that you have on a benchmark or a quiz or anything like that, very few would ever have capital letters in them. But you're only going to see that really in a formula here and there. Okay, we have some examples for you. I may or may not have given this to you in class, I'm not sure, but I want us to do a couple of these together. So I'm going to ask you to copy them, pause it, try it, and then come back and see how you do. So let me give you a couple numbers. I want you to do 1, I want you to do 6, and I want you to do 9. Give those a try. Come back and see us in a few minutes. Okay, here are your solutions. Okay, on the first equation, it's actually the volume of a prism. So we're dividing both sides by the area of the base. So volume divided by area of the base would equal the height. And number 6 is I equals PRT is another basic interest formula, principal times rate times time. If you divide off both the P and the T at the same time, you end up with R equals I over PT. And finally, if you have this one down here that is the volume of a 1/3 big BH. So a pyramid, I guess. So volume of a pyramid, you can multiply first by 3 to cancel those out. So you have a 3V. Then you could divide off the B. So 3V over B, as in boy, is equal to H. Let's try a couple more. And this will be the last part of the video. Let's do a couple of these. Let's do 13. Let's do 14, and let's do 16. So we're going to stick to the beginning ones here. So copy them down, try to solve them for the given variable, and then start your video again to see the solutions. Okay, here we go. Look at number 13. We want to get x by itself. Before I can get x by itself, I got to get ax by itself. So that means I'm going to subtract b from each side. So I now have ax equals the opposite of b, or negative b. All right, now I want to finish getting x by itself by getting rid of a. That means x is equal to the opposite of b over a, or negative b over a. So that takes care of 13. Look at number 14. Very similar, very, very similar, solving for x, except not a y on the other side. So we're going to subtract b from each side. And that's y minus b there equals mx. So after that, just to make sure the m goes away, we're going to divide it off. See, x equals y over b. X equals y over b all over m. Not all that useful, honestly, when you're solving a linear equation, but I'm sure you could find a good use for it. Alright, again, we're learning this so that we'll be able to solve multiple equations and be comfortable writing them as well. So this is our last one. Solving for y. So I need to get ax out of that picture altogether. Leaving by is equal to c minus ax. And now I finish off by getting y by itself. Divide by b. Now, I'm going to really try to give you this document. I want you to try other ones in class. It's important that you are making an effort to understand how to manipulate these. So if you need help, don't be afraid to ask. You know it's my job. That's why they pay me the big bucks. So, literal equations. Hope you enjoyed. All right then. See you in class.